write small. For A, mutually exclusive. The probability of A or B equals the probability of A plus the probability of B. All right, so that's all our theory, and let's do some practice with it. We filled in our chart and our notes. That's all the theory. As anything, I don't think anything is really new to you. I think you've seen it somewhere in your past. But if so, we'll pretend that you knew it all along. All right, on the first one, we're looking at distance learning courses. This is an example, and they're gaining popularity among college students, and they randomly select an undergraduate student who is taking a distance learning course for credit and records their age. So they learned from that study that ages 18 to 23, the probability was 0.57, and so on. So you can see the chart, what values were assigned for each age group. Show that this is a probability model, a legit. What would you have to test about that data to see if the probabilities work? What would I have to do with those 4 probabilities? Any ideas, Caleb? We're assuming that all the college ages are represented here.
Assuming they're all represented, if they all have to add up to 1.
They all add up to 1, do they? Or are they trying to pull a fast one on us?
They do.
They do. So that's all we have to really check to make sure that it is a good probability model. Find the probability that a chosen student is not in the traditional college age group.
Not possible.
Why? It's not. We were assuming that college starts at age 18 and goes to forever. So we can figure that out. What's the probability that the chosen student is not age 18 to 25? Yes, you can do that. And another way, you could add up the other 3. All right, Bailey, you add up the 3. Allie, you subtract. Tell me what you get.
Wait, I'm sorry.
Part B, find the probability that a chosen student is not age 18 to 23.
Oh, I thought it meant what, below 18.
No, it says not in the traditional meaning above.
That would be, but it would also not be in the traditional if you were 16
Yeah,
in
I
college.
know, that's true. We're not thinking of it that way.
But that's possible.
No, that's not what they meant. Okay, what'd you get?
43.
And same with you? All right, notice there's 2 ways to do that. You could add up the individual groups, or you could take the complement by taking 0.57 from 1. All right, let's look at the next example. We have adults with cholesterol, and A, you're considered A if your cholesterol was above 240 or above. And you're considered B if you're between 200 and 239. So, explain why events A and B are mutually exclusive. Remember, A is when you're at 240 and above. B is when you're between 200 and 239. So Caleb, do you think they're mutually exclusive? Can you be in both of those categories at once?
No.
No. If you cannot be in both of those categories at once, then they are mutually exclusive. You can't have cholesterol above 240 and also between 200 and 239. So therefore, the events are mutually exclusive. They do not overlap. All right, say in plain language what the event A or B is when I say, what is the probability of A or B? So in this case, Elena, what would that mean if I want to ask for the probability of A or B?
So you're just finding what the probability is Or it's what the chances that you would get the result of A or B.
Right, but you need to tell me what A or B is in plain language.
It's just the probability of A plus the probability of B.
No, I mean, what is A? They don't want you to use the word A.
Oh.
Okay.
Oh, the person that has the cholesterol of 240 milligrams.
And,
Or
sorry,
the person that has the 200 to 239.
right. So what they're saying in plain language, A or B is what she said. So the probability of having cholesterol between 200 and 239 or greater than or equal to 240.
So can't we just say the probability that their cholesterol will be greater than 200?
Yeah, you actually could. If C is the event that the person chosen has normal cholesterol, which is below 200, what's the probability of C? So would you calculate that for us, Allie, and enlighten us? The first group was 0.16, A and B was 0.29.
It would be 45%.
Sorry.
45% or 0.45.
Well, that's if you're an A or B.
That's if you're in A or B.
Right, so we want the probability that they're not.
Yeah, so 55.
0.55, right. So you had to add the 2 and subtract from 1. Very good. All right, our two-way charts are back. Remember how we used to love them? All right, I think you're ready for it this time. All right, look at the chart and observe you have pierced ears by gender. Yes or no? And then some totals. And I want to know, what is the probability of have the person chosen at random has pierced ears? So, Bailey, what is the number we divide by what to get that? What number would you pick for pierced ears divided by the total?
Do 103 divided by 170.
Right, do you see she's correct? 103 divided by 178, because 103 is the total. The question didn't say anything about male or female, so we don't care. We just care they're pierced. So the 103 is everyone that's pierced, in their ears anyway, divided by 178. 103 over 178. All right, part B is, try this one, Caleb, is a male with pierced ears, and they're talking about comparing it to the entire population. You could read that two ways. So, is a male with pierced ears out of everybody. So what two numbers would that involve?
19 and 178.
All right, 19 over 178. And part C got cut off, so would you write it down somewhere? Part C, is a male or pierced ears. This is a tricky one because we're adding two groups and we must be careful not to overlap them because some people are in both groups. So Elena, let's give it a stab here. Give it a pierce. Is it a male or pierced ears? So if we give me one number you think that will be involved.
Is a male or has pierced ears?
Yeah, so how many males are there?
There are 90 here.
That are 19 that are pierced.
No, 90.
I'm sorry, 90. 90 males. I thought you said 19. 90 altogether. But now, what other number, Elena, will I need to get the rest of the pierced people?
103.
Pardon?
103.
That's the total. See that if you use that number, you're double counting some of the males that are pierced. So 90 includes the pierced males and the unpierced males. So now where do I have to go to get anybody? Where do I have to go on this chart to get the rest of the pierced people? Pardon? Females, right. So what number is that? 84. So you're going to have to add 84 and the 90. So add Bailey's 84 to Elena's 90 You're gonna get 174 out of 178.
That's 98%.
Yeah, right, so notice, does it work in that case? Was the probability of being a male plus the probability of being pierced add up to that number? It doesn't. Right, because we're double counting if we do that way, because some people are in both groups. So those two groups are not mutually exclusive. Because you can be both at once. You can be a male and pierced. You can be a female and not pierced and pierced. So the groups overlap. So you can't do the rule that we found with the 5 and the 6 here. So you have to think it through extras differently. All right, let's go ahead then and put away that. Let me tell you what your assignment is. It's a little different than what it says there. On number 27, it's one of those simulations from last section. So I'll let you do that. Let's decide together how many we're going to do on it. How about 25? All right. So number 27, this is the new work. You're going to have to come up with a simulation, and you're going to test 25 people. So when you do your plan, and do 25. On 31 and 32, just make mention those are multiple choice, so that shouldn't take long. Instead of 43, let's do 44. And that's all I want you to do. Just those. So you can cross out 45 and 47. Got that? Video land, you got that? We're doing 27 and we're going to do 25 repetitions, 31 and 32, and then we're going to do 44 and we're going to scrap 45 and 47. We're scrapping 43
Perfect
too.
timing.
Perfect.
Perfect.
Bye.
Goodbye.